To the high availability meeting for the day, November 8th. So last week we talked about covering some comments on the AMD PR here, 271. And we also possibly had Prince coming to talk about BFD and ECMP. So I'm trying to get a hold of him here.
Yeah, I just joined,
Oh,
Krishna.
hey,
So
Prince.
yeah,
Hey, how's it going?
good, good.
Good, good. Okay. And I was trying to see if I needed to let someone else in. Lisa. Great. Okay, so yeah, why don't we get started with Prince? We went ahead. Maybe we can go over this with Gohan when and if he comes. The proposal 271. So I'll stop presenting here and maybe we can talk a little bit about BFD and ECMP that
Yeah,
we've had
so
for a
I
couple
have
weeks
one
now.
diagram to share, so I can share that.
Please
So
do.
it should cover for both the BFT and another proposal that we have been thinking. So let me um
Okay.
share the screen. Yeah. Um. So can you all see my screen?
Mm-hmm.
Um. Okay. So basically, in this approach, right? Let's say we have like appliance card. One is primary and another is backup. Um, So from a T1 layer, we can initiate some sort of configuration through the controller to advertise the BGP prefix that the appliance cards are advertising, right? And then um, the T1 can establish BFT sessions, right? With the cards, right? Basically the primary and backup. And based on the BFT's health, right, between the primary and backup, the T1 can determine what is the endpoint for that packet. So I have one. So let me also share um, one more uh, documentation. So that would be. Uh, so this is the BFT and overlay ECMP design document that we have in Sonic. So basically the idea is um, the routes or the prefixes are programmed at the T1 layer, and T1 will distribute the packet to different endpoints, right? So let's say these are the appliance cards, and in our case there are like some primaries and some backup. Uh, the T1 can be programmed in such a way that the controller can say, okay, hey, this is the endpoint one is the primary and two and three are say backup. Now the T1 can initiate BFT session to each of the endpoints, and when the primary goes down, based on the BFT session, right? Um, the T1 layer can reprogram the route to point to the backup endpoints, so that when the packet lands on T1, instead of going um, to the previous active endpoint, it will now go to the backups. So this health of the cards are determined by the BFT session. Does it make sense? Or so today we are using this idea for overlay ECMP hashing. Basically, the packet lands on T1 and it distributes the packet to all the different endpoints in an ECMP fashion. But the same thing we can extend to a active backup or primary backup scenario as well.
There's one question here. So the the BFT session and the tunnel endpoint, are they kind of related, or is it some custom logic to map which tunnel? I would imagine there is a tunnel from leaf one to tunnel endpoint one,
Mm-hmm.
right? And that there are three tunnels here, and one of the tunnel goes down to reprogram to go to the other two, I would guess, right? When the BFT
Yeah.
goes down. So is the mapping in this scheme, right? For example, the tunnel endpoint one has to be the source IP for the BFT session, or is there a separate mapping to say this BFT session corresponds to these tunnels? The identity is what I was
So,
looking at.
yeah, that's a good point. So, but from the controller perspective, right? So here is uh, uh, the table definitions, right? Like
I
what
see.
we have today. So basically, you can say uh, the endpoint is, so this is the prefix. Let's say this is the
Hmm.
VIP that is advertised.
Okay.
It can specify what is the endpoint IP, which is this endpoint IP, right? For that
I
prefix.
see.
And
Mhm.
then you can also say for that IP, what is the monitoring IP or the BFT IP.
This is a BFT session. Okay.
Yeah,
I
this
see.
is the BFT session. So from the schema, we have one-to-one mapping between. It can be same, like if the vendor or the implementation choose to have both the next stop IP and the monitoring IP to be same, it can be same, or it can be a different one that maps to
Got it.
this next.
Got it.
Yeah,
It can be mapped.
it can be mapped. Yes. So the T1 has the logic to map that session to this particular endpoint.
Got it. Yeah.
Correct. Yeah.
Thanks.
So yeah. So basically, it means like over here in the same schema, when we say endpoint and endpoint monitor, there will also be one more attribute that says primary, and it can say like IP address 1, IP address 2 are primary, and say if you have IP address 1, 2, 3, and 4, the implementation can infer that 3 and 4 would be the backups and 1 and 2 would be the primary. So it will basically start the BFT session with all the four. Um,
Mhm.
all the four monitoring IPs, and make sure that all the four are reachable or the BFT sessions are up. And when both the let's say 1 and 2 are primary, and if both primaries goes down is when it falls back to 2 and 3. The next stop will be changed in the hardware or the ASIC to choose 2 and 3 and 4, which are the new backup. Only if let's say the BFT sessions are up, okay. But um, now, one more thing is like if say the BFD session comes back with 1 and 2, then it will revert back to 1 and 2, the primary.
Is
As long
this yeah.
yeah.
Underneath, is it like a route with a bigger admin distance or a bigger metric or something, and one goes down, the
No,
other
no, no,
picks up?
no, no, no.
Oh, it's reprogrammed. I see.
It's just the hardware that programs with only the primaries or the active BFD
I
session
see. I
ones.
see. I see.
There's no longer prefix or shorter prefix here. It's basically the controller will program the T1 with the prefix and the endpoint IPs.
I see. Yeah. Okay.
So one question, Prince. So when the BFT session goes down, the controller intervention is required for the
No,
switchover, or
no, right? Because that's why the BFD session is between the T1 and the endpoint.
so the switchover happens
Is
on the
automatically had to
okay,
happen. Yeah.
okay.
Based on like today in the Sonic we have the hardware. This is hardware offload BFD. So the notification shall come to the Sonic layer that says that this BFT session is down, and then the Sonic Orc agent will have the logic to map that BFT session to this endpoint, and it will remove that endpoint from. Yeah.
Got it. So each leaf, the Sonic on each leaf is autonomously kind of monitoring the BFT session and
BFT
changing the
session.
routes.
Yes.
As
Yes.
okay.
Yes.
Okay.
So what happens if just one of the T1s loses its BFT session to the PU?
So one thing is in this case it kind of assumes that all the T1 should be having the same view, right? Like, for example, leaf 1 and leaf 2 cannot think this tunnel endpoint 1 is primary, but leaf here thinks that okay, this one is primary because it lost uh, the BFT session, right? So for that, one thing is whenever we do such switchover, the plan is to have some sort of alerting and monitoring so that the SDN controller knows that there is a this is the view of each of the T1 layer. But maybe to answer your question, there's no synchronization between the T1s. Okay, so the one thing that we thought about is to have the switchover being reported to the controller, and if controller sees that okay that's not right, then we need to take some actions around that.
So from the DPU perspective, if it loses connectivity to even one of the leaves or T1s, then it's supposed to switch over, although it has connectivity to other T leaves.
No, from the DPU perspective, there's nothing to be done, right? The switchover happens at the T1 layer.
Yeah, I guess Mukesh, your question is you are looking at the problem scenario where leaf 1, leaf 2 had one view while leaf n had another view. You are looking at that situation from the DPU's perspective, where the DPU still has leaf 1 and leaf 2, but leaf n connectivity goes down. Is that correct, Mukesh? Was that your?
Yeah. So the leaves go out of sync, like what Prince was explaining. Right. Also, from the DPU perspective, if in the active standby mode of operation, the standby is dropping packets, right? So
right.
The DPU also has to do a switchover. So if the active DPU has lost connectivity to just one of the leaves, while it still has connectivity to the other leaves, if the leaves synchronize and say, okay, we actually want to switch over to the standby, but the standby is not yet ready to accept packets unless the DPU level also has a switchover happening, right?
Right.
So there has to be some kind of handshake between the T1s and the DPUs, or I don't know, like probably we need to explore this.
Yeah, the only problem I see is if leaf n might be going through maintenance, which the DPU doesn't know.
No, in that case,
So that
we
is
will
the case,
definitely isolate the leaf n and disables the BFD between
okay.
Yeah. So like planned maintenance is covered, but the only concern is like in case of some unplanned
connectivity issue.
If the connectivity lows, then in case of active we don't have that issue because it will be always it can like even if the view changes, the packet can be sent to any of the cards, but in case of standby is where we have that issue. Yeah.
Okay, so currently I guess from the DPU side there is no linkage between the number of BFD sessions and the
yes.
What I'm saying is the BFD session and the HA state is kind of tangential. They don't intersect in any way, at least from the DPU perspective.
Yeah.
Right, Prince? So the states are independently going. Okay.
That's right.
Does that mean that the BFD states are tracked between the DPUs and the T1s here? And
so the BFD session is initiated from the T1 to the DPU. So when the controller programs the T1 or the leaf 1 is when the leaf 1 will start the BFD session with this endpoint or the card. So I don't see a requirement for the DPU to keep track of the BFD session because the T1, yeah.
I was thinking about keeping a DPU to keep track of the BFD session of the standby DPU, right? That's our connectivity path for the HA sync messages.
Oh, I guess are you referring to the heartbeat itself?
Right, heartbeat and everything. Yeah.
I see. Okay, I guess here the BFD in this context is not that. I guess it is just the BFD to the leaf. I guess right. The heartbeat is a separate thing. It could be BFD. It could be something else. The heartbeat between the DPUs.
Basically, we are trying to see if this BFD infrastructure can be used for heartbeat sake, right? That we are trying to achieve using achieve for HA between active and standby. If we are trying to see if we can utilize this BFD infrastructure, right? So then we will need the path from active DPU to standby DPU also. Unless we are
Right.
not trying to use that infrastructure for the HA heartbeat.
Right. So I guess, Prince, please correct me. My view, the way I'm understanding it is right. So there could be potentially, let's say, we use BFT as a protocol for monitoring monitoring DPU to DPU, the heartbeat itself, right? But that
Okay.
would be a special BFT session. I mean, what I'm
Right.
meaning is we'll
Separate
just call it
sessions.
heartbeat.
Yeah.
Correct. And it has got a special meaning too. Then these three, for example, these BFT sessions that we have. These BFT sessions have no bearing on the HS state, while whatever is there in the heartbeat, whether it's BFT or a different protocol, that has a bearing on the HS state of the DPUs.
Correct.
Right.
Yeah.
It's incidental that incidental that BFT could be used for the heartbeat too, but not related to this scheme, I guess. Apart from the commonness that it's the protocol is the same. Other than that, the functionality is very different.
So previously, when Gohan was suggesting to utilize the BFD infrastructure for the HA heartbeat as well, I was under the impression that, we can use it here. And also, if that is the case, further from this is that it can do multi-path probing or not just multi-hop, but multi-path probing, right?
Right.
Yeah. So that's the idea of BFT with overlay ECMP. So
Yes. Here, this thing itself in your previous this thing, or even the route that we have here, Prince. I think I have some idea, but the T1s, the leaves that advertise the route, are they kind of related to where the DPUs are placed, the appliance is placed, or it could be
So
actually anyway?
it could be in a different cluster as well, because these are like tunnel packets, right? So it doesn't
Yes, sir.
need to be like, for example, that's why this example was given, right? So from leaf 1, this card is in a different cluster, right? So it can some of it can take a direct path through the T0 if it is connected in the same cluster, but otherwise it will take the um, the T2 path and then go to another cluster because this is like within the same availability zone, and it can be reachable from this T1 to another and a card in another cluster. Yeah, there is no
My question
restrictions
is also,
basically. Yeah.
but my question is also from the failure domain kind of this thing, because if it's too far away, then I think the case you were saying with leaf and losing connectivity, but not leaf 1, leaf 2 becomes more probable.
Right.
If they are completely different failure domains, too far apart.
Yes, it's
in the
possible.
network.
Yeah.
This is within one class topology, one class, right? And it's within one availability zone.
Yeah, it's like within one availability zone, but it may be spanned across one or two clusters, because we want like the actual packets to land on different T1s, right? So,
Okay.
Prince, there is also the heartbeat is running on another IP, right? Control.
Yes. So it can, like I said, in the schema, it can be configurable. So if your next stop endpoint IP is let's say the cards PA, right? The monitoring IP can be the same or it can be a different one. So it depends on what the card wants to have the BFD session for it.
No, I meant so the VIP is what the T1 is advertising, right?
Correct.
So there is another IP that we are using for the heartbeat.
Mm-hmm.
Between so each DSC each DPU has its own IP for the heartbeat, which is
will
not
be
the same as the
the
PA.
kind of the PA address, right?
It's not the PA. It's another loopback IP. It's another WIP.
No, but that is up to the implementation, right? Like we can have the uh, PIP also for the BFT, but the BFT session will be established only when the card is ready.
See, I'm not talking about the BFD session. I'm talking about the who will advertise that. So, my understanding is this is a replacement for the BGP advertisement, right? So, if with this scheme we don't need to advertise BGP from the DPU, the BGP
Correct.
for the WIP. But we
Yeah.
also there's another IP that we advertise, with which the heartbeat. So when we want to connect to the peer for the heartbeat, the peer DPU, that
So-
IP is also advertised by the peer DPU in addition to this WIP today. So what will be the scheme for that IP? So we
So
call that control network IP and something like that.
But that is not for used for data traffic, right?
No, that is not used for data. It's just for the. That's actually used for the flow sync and the pulse sync and heartbeat and all that.
Yeah, I
Yeah.
think that.
Between two DPUs, they need to know that IP.
I mean, the question is
Yeah, but
is
my
it in
point is
the
it's
finite
not the PA.
space?
Yeah, it's not a PA. I don't know. We have to decide if that's also a PA IP or is that another IP?
So
Because the
in
PA
this
IP is usually the interface IP.
in this model, my understanding was it is in the PA space between the two DPUs. But if there is, because with this, like the advertisement will be done by the WIP advertisement is done by the T1, and the cards doesn't need to even advertise anything to the TOR, right? So and the endpoint or the next stop for the WIP is nothing but the PAIP of the card. So
Okay, so my understanding was that each card has two PA IP addresses, right? And this is a third IP.
two
that
PAIP. So there is like two PAIPs and then sorry Mukesh.
Yeah, and then another control network IP, which we today the plan is to advertise that also via BGP.
Yeah, I think the two L3 connected L3 interface PAIPs and then another loop back, which is used for the control network IP. That's also advertised through BGP. But if that control network IP is in the finite space, no data traffic hits it. It's only used for our flow sync. So if it's in finite space, we don't need the BFD mechanism. I guess that's the question.
Yeah, maybe that IP alone we may want to start the BGP and advertise through the current method, so that it will be there in the reachability.
Okay, so that will continue as BGP.
Yeah.
Okay.
Okay.
Hey, Prince, I have a follow-up question. In the current Sonic, like you mentioned earlier, it operates in active mode. So basically, the tunnel endpoint 1 and tunnel endpoint 2 can be receiving traffic based on the load balancing decision at leaf 1.
Yes.
However, with DPU, tunnel endpoint 2 will be standby, right?
Yes.
So let's say the BFD session between leaf 1 and tunnel endpoint 1 go down for whatever reason, but we have not triggered a failover from a DPU point of view. So if leaf 1 starts switching traffic to tunnel endpoint 2, which is a standby, DPU will not forward that traffic.
Correct. So that's
until
exactly,
the controller get notified and probably tell tunnel endpoint 2 to make the itself active. Is that the
No,
expected
that's
behavior?
not my understanding. I thought if, let's say, for any genuine reason, the tunnel endpoint 1 goes down, right? That's when the BFT has gone down, right?
Right.
In that case, there is an automatic synchronization between the two cards that the other one will switch over. I don't think a controller needs to notify. Um,
So then this would be another trigger for failover then? And also, right,
it is
this
definitely
may be a
orthogonal.
session that terminate on one particular endpoint only, right? I mean, ENI only, right? Do we really want to, I mean, are we just fail over that particular ENI, or what are we
Oh,
doing here?
that depends on the VIP, right? For each VIP, you have a endpoint. So if it is
Right.
different across different ENI, then it will be it will be basically but the
But right
PIP will
now,
be the same, right? So
yeah, but right now the control of who's active standby, that is dictated from the controller to the DPU, right? Because remember when the
but
controller
it
pushed
is
the information.
There is an administrative state which says that preferably this is active, this is standby, but the actual operational state is controlled by independent, in the sense if the active is not there, then the configured standby can become the active. Is that what you meant?
Yeah, so this will be a new trigger for changing the role.
no, from the DPU standpoint, there is it should not trigger anything based on the T1's BFT session.
No, let's
right?
say T1 BFD session go down between the leap 1 and the active DPU.
Okay.
So in that case, T1 will fail over the traffic to the standby, right?
Correct.
Okay, so standby is with the current behavior. If he is a standby, he will not forward any traffic. He'll drop it.
No, so the point is this went down because the active went down, right?
Not necessary, right? I mean, BFD depends on your BFD session. It can fail along the way. It's not necessary because of the DPU's fail, right? Your BFD session can go down for many reasons.
Okay, so the point is this is not a normal scenario where the active actually went down. It is like active is still up, but for some reason the BFT went down.
Exactly.
Right?
Yes.
So the BFT also is like there is like multiple retries. Like we have 300 milliseconds by 3 times. So if all the 3 went down, right?
Mm-hmm.
So all the 3, like let's say 3 retries of the BFT went down,
Mm-hmm.
and in that case, yes, of course, the T1 will make the switchover decision, because the T1 doesn't know whether it has actually went down or is it a physical networking connection, right? So
no, actually, Prince, between T1 and the DPU, it's a multipath BFD, right? So let's say any of the node along the way can fail, which cause a BFD session to go down. BFD session go down for many
This one
reasons,
has
right?
multiple different path, right? So even if let's say this one is connected to this store, right?
You're talking about multipath for the underlay.
Multipath for the underlay, yeah.
Underlay. So what you're saying is, if because this BFD session is running over VXLAN tunnel, the only way for it to go down, unless all the underlay paths are down, which is unlikely, or the other reason is the tunnel endpoint actually down, for which you interpret it as a DPU down.
DPU down, exactly.
For which a failover will happen.
Yes.
Okay, so then in this case, even though you're using BFD as a fast detection for failover, how much traffic loss will depend on the HA failover in this case?
Yes.
Unplanned failover. Okay, got it.
Unplanned failure. Exactly.
Which can be up to 2 seconds in this case.
Yes.
Okay, got it. So I guess that's the major difference between the current design, where you have active tunnel endpoint versus active standby in the DPU case.
Yes.
Okay, got it. Thanks.
The connectivity between endpoint 1 and T1 leaf 1, there could be multiple links there, and
Yes,
then if
yes.
one goes down, other will still remain active, for example. Now, if leaf 1 endpoint 1 connectivity to leaf 1 completely goes down, right? But endpoint 1 has connectivity to endpoint 2 via leaf 2 and others because they're all connected to the TORs and it's a clause topology.
Yeah.
Right. So from endpoint 1 connectivity to endpoint 2 point of view, there is still connectivity.
There
There
is
is
still
IP
connectivity.
receptor.
Yeah. If leaf any of the T1 going down is not a concern for us because it's like just isolating from the
Yeah.
network. But the only concern that we discussed in beginning of the meeting is, let's say if leaf 1 has a connectivity uh, to endpoint 1 but leaf 2 lost, and if leaf 2 decides to switch over, that will be like inconsistent between the two T1s, right? And that's when we wanted to raise it as a signal and alerting to the controller to, so anytime a switchover happens, so that um, if for some unknown reason, if any underlay network has gone down between the T1, but the T1 is still advertising, which means it's not isolated, then that needs to be um, like acted upon. There's no automatic way
Mhm.
to determine that. Yeah.
So Prince, for the clarity of thinking, the BFD sessions between the T1s and the endpoints are for a completely different purpose, right? This is for
yes.
how
Only
fast you can reconverge when there is a connectivity issue.
how fast we can reconverge and fall back to the standby, and also the other reason is with this proposal we don't need the cards to send different BGP session with AS prepend or something to tell the physical networking that, hey, I am inactive and that I'm in standby, right?
Absolutely.
So there are two things that we are trying to solve by this proposal.
Yeah. And what I was saying was, I mean, for the clarity of thinking, that whole purpose is met by these BFD sessions, and the heartbeat mechanism between the HA peers happen to use a BFD, but it's a completely different thing. So
It is completely different.
like,
Yeah.
you don't have to assume they're atomic and fail over at the same time. That's orthogonal to this.
Yeah.
Got it.
Yeah. Okay, yeah, I think that's all from my side. I'll stop sharing.
Thanks, Prince. I wrote down the link, so I'll put that in the notes. So, did you want the community here to go ahead and read through it and look at it? Prince?
Are we planning to tie this to the discussion that we have been having so far in HA, right? About the connectivity between the two DPUs and what would be the uh, reason for switchover, failover, right? Yeah. Is there any text in this PR that will connect with the DPU and the HA between the two DPUs? Or
No, this is a generic.
generic,
Yeah.
as in
Actually,
the way
so
it
I
has.
think from the dash perspective, you may need to add something there. Yeah. Sorry, Krishna, you were asking something. I missed that.
Did you want the community here to look at and review that PR, or are you just letting us know it's
Oh,
out there?
this is already one that is available
Okay.
in Sonic. Yeah. So
Okay.
there's no
Right.
PR on this. Yeah.
Okay, great. So I'll just post the link to it then.
Yeah.
Okay, great. And then I don't see Gohan on the call, Prince, but we did do some follow-up to the PR or the amendments to PR 244. And I believe Gohan will see those because those were basically his comments. So did you want to look at them here, Prince, or are we good just to let Gohan handle it?
Yeah, I think that one, let Gohan handle that. Yeah.
Okay, all right. Anyone on the call, do you have something you want to bring up before we close for the day? No? Okay, the survey responses I've received have pretty much unanimously said cancel for Thanksgiving week. So I'll probably go ahead and do that. And I'll bring that up again in the larger community meeting, just to let you guys know. That's what I'm hearing though. Okay. I'll
Yeah,
stop
that would
the
be good. Yeah.
Yeah, okay. So give everybody a break, right?
Yeah.